Hello, my fabulous fifth graders! This week we've been talking about adding and subtracting fractions using a double number line. I thought this time I would try a real-world problem that actually happened. We have this very special dog. Hello, my fabulous fifth graders! This week in math, we were covering subtracting and adding fractions using a double number line. And so I thought for this one, we would use a real-world problem that actually happened. Do you like going for a walk? I know my family does. We decided to go visit Calvert Cliffs. It's a pretty nice walk around, and it's beautiful this time of year with the changing colors. Well, we have this very special dog that we adopted, and her name is Athena, and she has an undeveloped brain stem. That means that sometimes her brain doesn't fully function or talk to her legs. And in this case, it happened. So Wobbles was walking and she didn't quite make it all the way to the beach. She made it about 5/6 of the way before her legs stopped talking to her brain. So what do? Well, we just pick her up and take her back. So we're going back to the car. My husband, he carried her about 1/5 of the way back before deciding that, you know what, we've got to figure something else out. This isn't going to quite work. So we used what we had around us. We grabbed some sticks, took the overshirt and my jacket, and we made a sling. She seemed pretty happy with this. And the girls did a fabulous job walking her back. In fact, they walked her 1/3 of the way back on top of what my husband did. Then the park rangers saw us. And they were like, hey, we can take you the rest of the way to the car. You don't have to try using that hammock through the woods. So we were very thankful. This is Keith, great guy, and helped us get back to our car by giving us a lift. So here's the question. What fraction of the trail did the park rangers drive us back to? Okay, we made it almost all the way back, but what fraction of it did they drive? So let's look at some important information in our story. We have Wobbles walked 5/6 of the way down there, right? Almost a whole. My husband carried her back 1/5, and then my daughters carried her back 1/3 on top of that 1/5 before the park rangers picked us up. So what do we know? Let's start with some things we know, because we know a lot about double number lines. We know a lot about fractions. Looking at the information we have, we know that Wobbles walked 5/6. Well, I could partition this into 6 pretty easily and mark 5/6 somewhere down here. We know it's only 1/6 away from the whole. Good. But then I have this 1/5. So then do I need to go back and partition it into fifths? Will those be equal pieces with my 6? And what about my 1/3? How can I make this so we're talking about all the same pieces? Do you remember? If you know how to do this, then pause it, go ahead and solve it yourself, and then come back and see if you got the right answer. Did you come back? So this is what we're going to do. We're going to find the common denominator. And what I mean by that is we're going to find the number that is a multiple of 6, 5, and 3. So 6 times something gives me this number, 5 times something gives me this number, and 3 times something gives me this number. The easiest way to do it, I have 6 and 5. Those are consecutive numbers. So if I multiply them together, I'll get 30. Does 3 go into 30? It sure does. So we can use that. Now I am going to partition this in half because I like to have reference points. So I have 15. I know 15 is half of 30. So now I got some numbers under me. Let's find out what 5/6 of 30 is. Well, I know it's 1/6 away from this whole. So what exactly is 5/6 of 30? How can we figure that out? It says to start with a unit fraction. Do you remember what unit fraction is? That's right. So in order to find 5/6 times 30, we're going to first start with 1/6 because that's our unit fraction. Now 1/6 of 30. Let's pull out those tiles again we used before. Give us a nice visual. So I have 30 tiles here. It is a 6 by 5. And I'm going to partition it into 6 equal pieces because I want 1/6 of that. Let's highlight one part. There you go. And I can count it easy enough to see that it's 5. You can also look at this problem and think, well, 6 times what gives me 30? And that'll help you out. Now we want 5 6, not just 1 6. So we're going to repeat this 5 times. So 5 times 5 is 25. And we have our 5 6 of 30 is 25. Now we can put that on our number line. There we go. All right, what's next? We have carry her back 1/5. So where am I going to do? Am I going to do another jump forward? No, we said back, right? So we're going to go back. So where is 1/5? How am I going to figure that out? Right, let's look back and see what's 1/5 of 30. So again, I'm partitioning this into 5 equal pieces, and I'm going to circle one of them. And again, we're going to see that 5 times what gave me 30? It was 6. So we have 1/5 of 30 equals 6. Great job. Now I can mark that by doing what? Yep, I'm going to take my 25 and I'm going to subtract 6. Now I can mark that. What's 25 minus 6? Stop, figure it out. Okay, we have 9, right? So it's, 19, sorry, so it's 19. And then we mark it on our thing. It's a little bit more than 15, so I know where to put it. And I am going to put the same thing on the top, right, with my fraction. So I subtracted 1/5 from 5 6. Now I'm going to look at my 1/3. So I'm going to do the same thing. I'm going to figure out 1/3 of 30 is what, right? Oh, look at this tile thing. I'm back to this. Can I partition this into 3 equal groups? Sure can. There you go. And then I circle one of them, and easy peasy, 3 times what gives me 30? That's right, 10. 3 times 10, or 1/3 of 30 is 10. Great job. So now I'm going to take the 10 and I'm going to subtract it from my 19. And I'm going to do the same with the fraction, subtracting another 1/3, and I end up with 9. Well, let's see, how is that really making sense to us with these fractions? So let's look at it with the fractions lined up. In the story, using the number line, we discovered that 5 6 was equivalent to 25 30ths, and 1/5 that we subtracted from this 25 30ths was equivalent to 6 30ths. Then we subtracted again 10 30ths to get our 9 30ths. I hope this was helpful, and have a great day.